So recently I've had some questions about wrap and the surfacing tools inside of wrap. So most people, when they look to purchase wrap, the way we position the product primarily now is selling it for scan processing, scan cleanup, and then secondary um, fitting surfaces to the geometry. And then a third reason why people tend to pick up wrap is for its scripting capabilities and the access that we give you to the code to be able to write your own software kind of on top of wrap as a platform, or using wrap as a component of your software. So that scripting is another option. But again, going back to polygon cleanup is one thing, but surfacing, I get lots of questions at because the way surfacing happens in here is very powerful, and many people in the past have used it quite a bit. But recently, people have fallen off the radar as far as the experts on this. So I wanted to give some tips and tricks as the different styles of surfacing that I use on a regular basis inside of wrap. There will be other things outside of what I cover here, but I'm just trying to use a very simple model that can show some different strategies to surfacing objects inside of wrap. So the first thing you're going to do is I'm going to take this mesh model and toggle over to the exact surfaces tab and hit exact surfacing. When you do that, it kind of converts that object over to an exact surfacing object. It's still a polygon, but it converts it over to that exact surfacing object to work with it. It's kind of a platform thing. From here, there's two different main routes you can go. One of them is the auto surface route, and the other one is manual surfacing route, which is everything here. And then at the very end of the line here, you can convert it back to a polygon again. So real quick, the auto surfacing, everybody knows we're famous for this. One thing that I like about our auto surfacer is this interactive mode, which is really neat. So if I go ahead and run auto surface, we're basically telling it this is a mechanical part or organic part, which I just left it on mechanical. It's just two different approaches, giving the software more or less flexibility to try to make structured patches and how it defines the patches and stuff. You can run either or, it doesn't matter. But the interactive mode, I kind of selected this one on purpose because interactive mode will find more things if I try to run mechanical on this part. So here it says, we found some patch problems. There are 16 of them. Do you want to fix them manually? So with interactive mode, just like the term infers, it'll stop in process, and this walkthrough mode down here is really neat. It'll allow you to come in here and say, I will drag that point over there. So now there are 14. And you'll see here, you can kind of sort out some of these problems along the way. And again, some of these problems are basically caused because I selected an algorithm that specializes in a different type of part. But again, part of the reason why I did it is so we would have something to fix here. But mainly, these are the things that it will find are poor patch angles. And many times the patch angles aren't really that big of a deal. Now, obviously in that one, that specific case right there, it's going to have some like surface wrinkles. So if you think about surfacing like upholstery, I always use this term, you're kind of like taking square pieces of fabric and wrapping them around the shape of this polygon. And if you're an upholsterer, you can wrap them in a way that will cause wrinkles, right, in the surface. And that's kind of what happens here because you have only square patches that's defined by NURBS. And the patches, if you don't lay them out properly and you stretch them in different directions, you can kind of cause wrinkles as it tries to fit to the underlying geometry. So I'm not going to go ahead and fit all these, but I can just say, hey, those are the ones I want to fix, hit done, and then it will finish out the surface. And it will go ahead and finish calculating.